The European Space Agency, ESA, is currently working on a space mission with important implications for the future of space transportation in Europe. After being launched into space, the IXV, or Intermediate Experimental Vehicle, will return to Earth as if from a low Earth orbit mission, testing brand new European atmospheric re-entry technologies during its hypersonic and supersonic flight phases. For ESA, the mission is essential to develop critical technology further for future robotic or manned spacecraft.
We have noticed from the past that by embarking in large developments without having a strong know-how on the basic technology that you need to support such developments may create increased risk in the big operational developments. That's why we have decided to develop such an intermediate experimental vehicle. So intermediate in the sense that it starts on the ARD achievements and it performs the intermediate step towards future developments.
The IXV will be launched on board Vega, Europe's new small launcher from Kourou in French Guiana. After re-entering the Earth's atmosphere and being slowed down by friction from a speed of 7.5 kilometers per second, it will descend by parachute and land in the Pacific Ocean to await recovery and post-flight analysis. As IXV flies through the Earth's atmosphere, its 2-hour mission will include a set of automated maneuvers. This will allow scientists and engineers to test in situ the systems which ensure its safe return to Earth under huge extremes of temperature.
What we want to understand is basically the performances of the key critical technologies for re-entry, which are thermal protection, guidance, navigation, descent and recovery systems, when undergoing from 120 kilometers altitude, so when the atmosphere starts to be felt, down to a landing, because of the very harsh environment, thermal environment. As we know, we encounter temperatures up to 1,600 degrees, and therefore it is not through the use of conventional technologies that we can withstand such environment. Therefore, we did in the past a lot of developments on the technological side on ground. Now it is the time for Europe to address its integration, the integration of this technology at the system level, so that we can address the full design loop of such a re-entry vehicle.
Scheduled for launch in 2012, IXV follows on from ESA's atmospheric re-entry demonstrator launched in 1998. As a part of ESA's Future Launches Preparatory Program, it'll play an important role in the design, building and testing of an autonomous launch and controlled re-entry system for Europe.